What is light? If we enter a dark room, the objects present in the room are not visible. However, if we switch on a bulb, everything in the room becomes visible. Why? The bulb gives out an invisible energy called light. When this energy falls on the objects in the room, it bounces off from the surface of objects. When this energy enters our eyes, the eyes sense it and send a message to the brain. It is finally the brain which really sees the objects. Eyes are only an aid in seeing the objects around us. Why do we say that light is invisible? Well, when light energy falls on the objects, we really do not see it. When energy bounces off from the surface of objects and enters our eyes, the sensation produced by this energy helps our brain to see. Thus, to sum up, we can say, light is an invisible energy which causes in us the sensation of vision. When the light falls on any object, it bounces off from the surface of the object in all directions. This is called scattering of light. Definition. Light is a form of energy which enables us to see objects which emit or reflect light. Light is a type of energy which can produce sensation in our eyes, so we can experience the sensation of vision. It travels in a straight line in the form of particles and waves. With the help of light, we see all colors of nature. Our eyes are mostly sensitive to yellow color and least sensitive to violet and red colors. Due to this reason, commercial vehicles are painted with yellow color and sodium lamps are used in road lights. Optics. It is a branch of physics which deals with the study of light. It is mainly divided into three parts. Geometrical optics or ray optics. It deals with the reflection and refraction of light. Wave or physical optics. It is concerned with the nature of light and deals with interference, diffraction and polarization. Quantum optics. It deals with the interaction of light with the atomic entities of matter, such as the photoelectric effect and atomic excitation. Nature of light. Theories about the nature of light, particle, nature of light, Newton's corpuscular theory. According to Newton, light travels in space with great speed as a stream of very small particles called corpuscles. According to this theory, the reflection and refraction of light are explained, while this theory failed to explain the interference of light and diffraction of light. So the wave theory of light was discovered. Wave nature of light. Huygens considered that light remains in the form of mechanical rays, and he considered a hypothetical medium like ether for the propagation of light waves. So, light waves are declared electromagnetic waves. So there is no need for a medium for the propagation of these waves. They can travel in a vacuum also. The speed of these waves in air or in a vacuum is maximum, that is 3 times 10 to the power of 8 meters per second. The photoelectric effect was not explained with the help of wave theory. So Planck gave a new theory which was known as the quantum theory of light. This theory failed to explain the photoelectric effect. Quantum theory of light. According to Planck, light travels in the form of energy packets or quanta of energy called photons. The rest mass of a photon is 0. Each quantum carries energy E equals hv. H is Planck's constant, which is 6.6 times 10 to the power of minus 34 joule seconds. V is the frequency of light. Some phenomena like the interference of light and diffraction of light are explained with the help of wave theory, but wave theory failed to explain the photoelectric effect of light. It was explained with the help of quantum theory. So light has a dual nature of light. De Broglie explained the dual nature of light, that is, wave nature and particle nature. Wave nature. Light is electromagnetic waves. It is transverse in nature and propagates in a vacuum. Particle or photon nature. With the help of this theory, Einstein explained the photoelectric effect. Source of light. A body which emits light or reflects the light falling on it in all possible directions is said to be the source of light. The source can be a point 1 or an extended one. The sources of light are of 2 types. A. Luminous source. Any object which by itself emits light is called a luminous source. For example, the sun and stars are natural luminous sources, while electric lamps, candles and lanterns are artificial luminous sources. B. non-luminous source. Those objects which do not emit light but become visible only when light from luminous objects falls on them. These are called non-luminous sources. For example, the moon and planets are natural non-luminous sources, while wooden tables are artificial non-luminous sources. Medium of light. A substance through which light propagates or tends to propagate is called a medium of light. Our eye, transparent object. Bodies that allow light to pass through them, that is, transmit light through them, are called transparent bodies. For example, glass, water and air. You, translucent object. Bodies that can transmit only a part of light through them are called translucent objects. For example, frosted or ground glass, greased paper and paraffin wax. 3. Opaque object. Bodies that do not allow light to pass through them at all are said to be opaque objects. For example, chairs and desks. Note, depending on composition, optical media are divided into two types. A homogeneous medium. An optical medium which has a uniform composition throughout is called a homogeneous medium. For example, vacuum, distilled water, pure alcohol, glass, plastics and diamond. 2. Heterogeneous medium. An optical medium which has different compositions at different points is called a heterogeneous medium. For example, air, muddy water, fog and mist. Behavior of light at the interface of two media. When light traveling in one medium falls on the surface of a second medium, the following three effects may occur. I. A part of the incident light is turned back into the first medium. This is called the reflection of light. 2. A part of the incident light is transmitted into the second medium along a changed direction. This is called the refraction of light. 3. The remaining third part of light energy is absorbed by the second medium. This is called absorption of light. Characteristics of light. Some common characteristics of light are given below. I. Light has a dual nature, meaning it exhibits both wave and particle properties. 2. Light is an electromagnetic wave. 3. Light does not require a material medium for its propagation, meaning it can travel through a vacuum. IV. The speed of light in free space or vacuum is 3 times 10 to the power of 8 meters per second. Its speed is marginally less in air and decreases considerably in glass or water. V. Light undergoes reflection from polished surfaces such as mirrors and so on. 6. Light undergoes refraction when it moves from one medium to another. Ray optics treats the propagation of light in terms of rays and is valid only if the size of the obstacle is much greater than the wavelength of light. It concerns itself with image formation and deals with the study of simple facts such as rectilinear propagation and the laws of reflection and refraction by geometrical methods. A ray can be defined as an imaginary line drawn in the direction in which light is traveling. Light behaves as a stream of energy propagated along the direction of rays. The rays are directed outward from the source of light in straight lines. A beam of light is a collection of these rays. There are mainly 3 types of beams. I, parallel beam of light. A searchlight and the headlight of a vehicle emit a parallel beam of light. The source of light at a very large distance, like the sun, effectively gives a parallel beam. 2. Divergent beam of light. The rays going out from a point source generally form a divergent beam. 3. Convergent beam of light. A beam of light that is going to meet or converge at a point is known as a convergent beam. A parallel beam of light, after passing through a convex lens, becomes a convergent beam. How we see. When a light ray strikes the surface of any object, it reflects and reaches our eyes. Due to this, our eyes experience a sensation, allowing us to see the object. Reflection of light. When rays of light fall on any object, they return back in the same medium from the surface. This phenomenon is called the reflection of light. Due to reflection of light, we can see all the nature around us. Incident ray. The ray of light which falls on a polished surface or a mirror is called the incident ray of light. Reflected ray. The ray of light which gets reflected from a polished surface or a mirror is called the reflected ray of light. Normal. The normal is a line at a right angle to the reflecting surface. Laws of reflection. First, the incident ray, the reflected ray, and the normal to the surface at the point of incidence all lie in the same plane. Second, the angle of incidence is always equal to the angle of reflection, meaning I equals R. When a ray of light falls on a mirror normally or at a right angle, it gets reflected back along the same path. A ray of light striking the surface normally retraces its path. Explanation. When a ray of light strikes a surface normally, then the angle of incidence is zero. That is, I equals zero. According to the law of reflection, R equals I, so R equals zero, meaning the reflected ray is also perpendicular to the surface. Thus, an incident ray normal to the surface, or perpendicular to the surface, retraces its path. Laws of reflection are also obeyed when light is reflected from spherical or curved surfaces. Depending on the nature of the reflecting surface, there are two types of reflection: regular or specular reflection and irregular or diffused reflection. Regular reflection. The phenomenon where a parallel beam of light traveling through a certain medium, on striking, becomes a parallel beam in some other fixed direction is called regular reflection. Regular reflection takes place from objects like mirrors, still water, oil, and highly polished metals. Regular reflection is useful in the formation of images. For example, we can see our face in a mirror only because of regular reflection. However, it can cause a very strong glare in our eyes. Irregular reflection, or diffused reflection. The phenomenon where a parallel beam of light, traveling through some medium, gets reflected in various possible directions on striking a rough surface is called irregular reflection, or diffused reflection. The reflection that takes place from the ground, walls, trees, suspended particles in the air, and a variety of other objects which are not very smooth is irregular reflection. Irregular reflection helps in spreading light energy over a vast region and also decreases its intensity. Thus, it helps in the general illumination of places and helps us see things around us. Note: the laws of reflection are always valid, no matter whether the reflection is regular or irregular. Rectilinear propagation of light. In simplest terms, rectilinear propagation of light means that light energy travels in straight lines. Examples of rectilinear propagation of light in everyday life include: when sunlight enters through a small hole in a dark room, it appears to travel in straight lines. The light emitted by the headlight of a scooter at night appears to travel in straight lines. If we almost close our eyes and try to look towards a lighted bulb, it appears to give light in the form of straight lines which travel in various directions. Experiment to prove rectilinear propagation of light. Take 3 wooden uprights, A, B, and C, having a small hole in the middle, such that the holes are at the same height from the base. Arrange the uprights along the edge of a table, such that the holes are in the same straight line. Place a lighted candle towards upright A, such that it is facing the hole. Look through the hole of upright C. The candle flame is clearly visible. Now displace upright B slightly towards the right or left. It is seen that the candle flame is no longer visible. This shows that light travels in straight lines. Reflecting material. The material or matter which reflects the light rays is called reflecting material. There are 2 types of reflecting material: good reflector and dim reflector. Good reflector. The material which reflects all the incident light rays is called a good reflector. Or, these types of reflectors reflect maximum incident light rays. These types of reflectors make regular reflection like a mirror, dim, or medium reflector. In this type of reflector, mostly part of incident rays are reflected, but some part is absorbed or transmitted by them. Irregular or diffused reflection is made by them, like a rough surface. For making a reflector, a glass plate is polished on one side with silver or nickel-type material. Mirror. A smooth, highly polished reflecting surface is called a mirror. When a glass plate is polished on one side with reflecting material such as silver or nickel, then it becomes a mirror. From the reflecting surface of a mirror, there are 2 types of mirrors: plane mirror and spherical or curved mirror. A highly polished plane surface is called a plane mirror. Or, if a flat, totally plane surface of a glass plate is polished on one side with reflecting material, It is called a plane mirror. A spherical mirror. A mirror whose polished, reflecting surface is a part of a hollow sphere of glass is called a spherical mirror. For a spherical mirror, one of the two curved surfaces is coated with a thin layer of silver, followed by a coating of red lead oxide paint. Thus, one side of the spherical mirror is made opaque, and the other side acts as a reflecting surface. For the polishing side, there are two types of spherical mirrors: convex mirror and concave mirror. A concave, or converging mirror, is a spherical mirror whose inner hollow surface is the reflecting surface. A convex or diverging mirror is a spherical mirror whose outer bulging out surface is the reflecting surface. Formation of image in a plane mirror. P is an object which is placed in front of a plane mirror AB. Rays PO and PO starting from P fall on the mirror. Then these rays are reflected in OR and OR directions respectively. When the reflected rays enter the eye, they appear to diverge from P. P is called the image of object P. Following are the properties of the image formed by a plane mirror. The image is always virtual. The image lies as far behind the mirror as the object is in front of it. The size of the image is the same as the object. The only difference is that the right side of an object appears to be left in the image and vice versa. This effect is known as lateral inversion. Uses of plane mirrors. They are used as looking glasses. They are used by barbers to show the customer the backside of his head. They are used for signaling by the scouts and the army personnel. They are used by opticians to provide false dimensions when their place of work is very small. They are used for providing false dimensions in showcases, displaying jewelry, wristwatches, etc. Two plane mirrors are fixed to the opposite sides of the showcase, such that their reflecting surfaces face each other. This leads to the formation of multiple images. They are used for reflecting the rays of the sun inside the solar cooker. They are used for making toys like Collidoscopes. In this toy, 3 plane mirrors are inclined at an angle of 60 degrees and fixed in a tube. Some broken bangles are placed inside the tube. When the tube is turned, the image of bangles forms beautiful hexagonal patterns. Terminology for spherical mirrors: aperture. The effective width of a spherical mirror from which reflection can take place is called its aperture. The line joining the endpoints of a spherical mirror is called the aperture or linear aperture, pole or vertex. The center of a spherical mirror is called its pole, and it is denoted by the letter P, center of curvature. The center of the hollow sphere of which the spherical mirror is a part is called the center of curvature. It is denoted by the letter C, radius of curvature. The radius of the hollow sphere of which the spherical mirror is a part is called the radius of curvature, or R, principal axis. The straight line passing through the center of curvature C and the pole P of the spherical mirror. Normal. The normal at any point of the spherical mirror is the straight line obtained by joining that point with the center of curvature C of the mirror, principal focus or focus. The point on the principal axis where all the rays coming from infinity or parallel rays after reflection either actually meet or appear to meet is called the focus or focal point of the mirror. It is denoted by the letter F, focal length. The distance between the pole, P, and the focus, F, is called focal length or F focal plane. An imaginary plane passing through the focus and at right angles to the principal axis, real image. When the rays of light, after getting reflected from a mirror or after getting refracted from a lens, actually meet at a point, a real image is formed. A real image can be obtained on a screen, virtual image. When the rays of light, after getting reflected from a mirror or after getting refracted from a lens, appear to meet at a point, a virtual image is formed. Such an image can only be seen through a mirror or a lens, but cannot be obtained on a screen. Paraxial rays. The rays which have a very small angle of incidence are known as paraxial rays. Rules for image formation. The reflection of light rays and formation of images are shown with the help of ray diagrams. Some typical incident rays and the corresponding reflected rays are shown below. First, a ray passing parallel to the principal axis after reflection from the spherical mirror passes or appears to pass through its focus. This is by the definition of focus. Second, A ray passing through or directed towards the focus after reflection from the spherical mirror becomes parallel to the principal axis. This is by the principle of reversibility of light. Third, a ray passing through or directed towards the center of curvature after reflection from the spherical mirror retraces its path. This is because the angle of incidence is zero, and so the angle of reflection is also zero. Lastly, it is easy to make the ray tracing of a ray incident at the pole as shown below. Now let's look at the uses of concave mirrors. First, it is used as a shaving mirror. Second, it is used as a reflector in the headlight of vehicles. Third, it is used by doctors to focus a parallel beam of light on a small area. As for convex mirrors, they are used as rear-view mirrors in automobiles. They are also used as reflectors for streetlights. It is important to note that a plane mirror is not useful as a rear-view mirror because its field of view is very small. Multiple reflections. A plane mirror forms an image of an object placed before it. This is the result of a single reflection of light. But what happens if the object is placed between two mirrors that are at an angle to each other? Let us find out. Each of the mirrors will form an image due to reflection. Each of these images is formed by a single reflection. These images are laterally inverted. Additionally, an image is formed at the edge where the mirrors meet. This image is formed by rays that get reflected twice. As a result, this image is not laterally inverted. So the left and right sides of the arrow and the word left appear the correct way round in this image. Note, the number of images of an object placed between two mirrors can be found from the following formula. When the angle between the mirrors is 90 degrees, the number of images is 3. Similarly, when the angle is 60 degrees, the number of images is 5. Kaleidoscope. The kaleidoscope is a device that uses reflections to produce patterns. It consists of mirrors inclined to each other. The mirrors form multiple images of objects in front of them. This creates beautiful patterns, which change when the kaleidoscope is rotated or shaken. Periscope. The working of a periscope is based on the principle of successive reflections from two plane mirrors. It consists of two plane mirrors M1 and M2 facing each other fixed at 45 degrees to the framework of a tube which is bent twice at right angle. A beam of light from some object is turned through one right angle by the mirror M1. In the same way, the light is deviated through another right angle by the mirror M2. Therefore, the object is seen by the eye in spite of the obstacle. This arrangement can be used by a person to see a match over the heads of a few people while standing at the back of the crowd. Even an object can be seen through a wall as well by an arrangement as shown in the figure. In this case, light from the candle is reflected by 4 mirrors, M1, M2, M3 and M4, before reaching the eye. Therefore, the candle is seen through the wall. Lateral inversion in a plane mirror. When we place any object in front of a plane mirror, its image is such that its left-hand side is seen on the right-hand side and the right side is seen on the left. Figure shows a boy, as you will see him when he stands before you. Now make him stand in front of a mirror and see his image. Note that the flower on the coat now appears to be on the right side, and when you see him directly, the flower on the coat is on the left side. Similarly, if you write with your right hand, the image in the mirror shows as if you are writing with your left hand. This phenomenon of left appearing right and right appearing left on reflection in a plane mirror is called lateral inversion. Another example of a lateral inversion is if you write letters ABC on a piece of paper, they will look different when seen in the mirror. You can see that the letter A has gone from the left side to the right side in the mirror. Not only this, but each letter has gone through a lateral inversion. Letter B becomes reversed, and C has become reversed as well. Can you now tell why A remains as A when seen in the mirror? Characteristics of an image formed by a plane mirror. Thus we summarize that the image formed in a plane mirror has the following characteristics. 1. The image is virtual and erect. 2. The image is laterally inverted.